Okay, we're going to go ahead and get started. Chat. Okay, we need to go through this so that you guys don't whine too much afterwards here, okay? You guys don't whine, do you? You guys are a bunch of winos. No. Okay. We'll review the oxygen and silicon that we did. Okay? Devin, you missed, right? Yesterday? Okay. So you're going to have some questions. All right? And some others will have questions. Some of them are getting them down pretty good. You have to use your periodic table as a map. If you don't use your periodic table, you're not going to get them right. Okay? And your map starts with hydrogen. Okay? It's kind of like going down the yellow brick road. Didn't they have that Wizard of Oz here not too long ago? You had to follow the yellow brick road to get to where? Oz? Land of Oz. Okay? So our beginning point is always going to be hydrogen. Okay? For a few of them. Okay? We're not going to start at hydrogen every time. It's just, John, becomes a little bit laborious when you start at hydrogen every time. You have to go to like the element where you guys show all the electrons. Okay? After doing a few of them, you should not have to start at hydrogen every time. Okay? You'll have a different starting point that you can go to. You have to use your periodic table. You have to understand where the periodic table starts, and then where the different subshells are. If you know where the different subshells are, then you know what's being filled, at least the subshell anyway. All right. So yesterday I gave you a way to say if it's first, it's the S's, and if it's a second, we have S's and P's. If it's a third shell, or third energy level, you have S, P's, and D's. If you have the fourth, it's S, P, D's, and F's, and that's where they come in. That's a very important thing that you have to know. You have to know where the subshells are coming in. If you don't know where the subshells are coming in, you're not going to get it right when you have to do the configurations. The D's come in the third. What do you think is filled first? A 3D orbital or a 4D orbital? 3D. Why? Not everyone. One person. Who wants to answer it? What's that?
Chloe.
Chloe? No? Lowest energy, right? It's the lowest energy. Because a 3D is lower than a 4D. I'll have some students that want to fill a 4D before they do a 3D when they do an electron configuration. Okay? So you have to know where they come in, and then guess what? They always are going to occur in the next shell after that. So just in that sequence. Okay? Now, if you have to do an F on a test or something, it'll be just one of them. So there'll just be one that you'll go through the F's. Okay? Because those can be a little confusing in that, but a lot of you would do okay on it. If we would do a bunch of them, the F's, you'd be fine. Okay? Now, another thing you can think of is these shells and when they fill. Okay? But you got to be careful of this, and the reason why is because they don't fill the shells after a certain point in time, they don't fill the shells all the way. Meaning that they'll go to other shells before they fill up totally. Okay? And I'll explain that here in a second, or when we get to it. But the first couple will fill, then after that they won't fill all the way up before other shells start to fill up. Okay? So they don't go in a perfect order. You would think 2 electrons, that one will be filled, and then 8 electrons, that one will be filled, and then 18. But this one will not be filled before the fourth starts to fill. Okay? And I'll explain that when we get there. I'll explain that, why that's the case. All right? But these two will fill with 2 and 8, but when you get to the third shell, it won't completely fill. All right? And there's some reasons for that, and we'll get to that and talk about that. But if you use your periodic table, Your periodic table will never lie to you what subshell you're in if you know where they come in. All right? So what I mean by where they come in is that we have these first two, they're kind of the odd ones, hydrogen and helium. 1s2, 2s2. And then we get those, then we have these other blocks of elements that we can look at. Okay? So those two are kind of the oddballs out. And so what shell is being filled here in this section? S's, right? So this is the S block. I'm going to put S right there. And then this block is what? The what? Nope. D, as in dog. And then this shell is the P's. Because when they go in sequence, don't they go like 1s2, 2s2, 2p6? And we don't have the D's until later on. So we don't have the D subshells being messed with until later on. And I'm not going to put the F's down there, but the F's will be down here, down below. So when you follow your periodic table, you know exactly what subshell you're in. You just have to figure out the shell. I'm going to tell you an easy way to figure out the shell for the S's and P's. It's the row, it's the period number. Okay, what's this period number going across? The first row, what's that period? Period what? 1. What's the second row going across? Period 2, period 3, 4, 5, 6, 7. Okay? If you number those tell you what the S's and P's are. So if you know where you're at, and this is a map, we always start here and we go to the right, then when we run out of elements, we come back, like reading, left to right, come back, left to right, come back, so on and so forth. You just keep going until you get to the element you want. When you get to the element you want, then you're done. Okay? So please use your periodic table. It'll make a lot of sense once we use that. We go through that. So remember we did oxygen, right? We did oxygen. So we did oxygen. Oxygen's 1s2. Where are you at on your periodic table right now? Right here. If you got your periodic table out in front of you, we'll do that. So where are we at right now? Helium, right? You guys find helium? Helium's 1s2, by the way. You hope you get that on a quiz. It's easy. Okay? The only one easier than helium is hydrogen, right? So that's 1s2. Yes, John?
So if you start at 2s3, would you be at?
Well, for one thing, you wouldn't have the free because S's can only hold 2. So everything.
2s2.
So right here, this is the second row across.
So that way you would be on beryllium.
Right. So if we go 2s, so the next thing we do is we can say 2s2 on your map. We're going in sequence from one element to the other, or groups. So right here is where we're at.
So could you just start with 2s2 and be?
Well, there is a starting place that's got to be the same for everybody. Because if everybody chose whatever starting place they wanted to go, then there would be just chaos. So there is a element or a group of elements we'll start with, so to shorten this method up, so we don't have to start at hydrogen every time. Okay. So and we'll get to that in time. All right. So then the next thing we did, oxygen's about right here. And it's 1, 2, 3, 4th element in the P's. And it's the second period of the P's, and that coincides with the second shell as well. So then you go 2p4, and that's what we did yesterday, right? That's what we have? Okay, and then we did the lines underneath. You guys remember the lines. Why does the P have 3 lines and the S only has 1? Because why? Yeah, they have the arrows, but why do I put 3 for the P's?
One goes one way and the other goes the other way.
Right, so when we put arrows in, they go, one goes one way and one goes the other way, but why 3 of them? Yes?
Because they can have 3 orbitals.
They can have 3 orientations. They have 3 orientations, S's can only have 1. So when we fill them in, they have to pair up if that's the only orbital that we have, like the S's, they have to pair up right away. But the P's don't have to pair up until they each have 1 in them. And once they have 1 in them apiece, then if they are required to start filling up, they'll fill up. And that's why we do the orbital notation for that. Did we do orbitals yesterday? Okay, because some classes I'm pretty sure all the classes we've covered, but, you know, days kind of blend in, periods kind of blend in together. So questions on that one. That's oxygen. Okay? Now, you guys, we also did silicon, right? So follow along where we're at. We're always starting with hydrogen to begin with, and then we'll have different starting place later on. So 1s2. 2s2. Where we at? Beryllium? 2p6. Where we at? Neon. 3s2. Where we at? Calcium. 3p. Is it 2? And is that silicon or not?
Sorry, that's...
Yeah.
Oh, magnesium. I'm sorry. Magnesium is 3s2, and then 3p2 is silicon, right? All right. Now I'm not going to show you the lines underneath, but that would be like. Is there anything that confuses you at this point of how we're proceeding through the periodic table and how we're doing it, John?
So if you had to go into the D's.
Okay, if we had to go on, all right, he's getting ahead of me here, but we'll talk about it here in a second. If we go to the D's, where do they come in?
After the P's.
Not right after the P's, but what shell do the D's come in? The third, right? Right? Didn't we have that? The third. The 3 Ds, we had that on one of the slides. Okay? D's. The third. Okay? We said that. They come in the third. All right. We'll get to that, John. We'll get to that. That's the most important thing we're going to do today is how to treat the D's. Because we know how to do the S's. We know how to do the P's. Now, I'm going to give you one to practice, and a lot of you are going to get it wrong. You're going to get some of it right, but then you get some of it wrong. Some of you might be able to figure it out with following the periodic table. I want you to do manganese. I want you to go through and see if you can write a configuration for manganese. That's just a few more than we did with silicon. Okay? So I want you to write it all from hydrogen all the way to silicon. And don't do the lines underneath, because, you know, if you mess up on the top portion, the bottom portion will be messed up. Try not to look at their answer. Okay? If you guys look at their answer, it's going to mess you up. And then try to do it without copying your previous silicon. Don't copy silicon. Try to do it from without looking at it, like knowing the process of going from hydrogen all the way and knowing where you're at on the periodic table. If you can do that and you continue to do that, you shouldn't have issues later on when you have to do maybe a short version of it. So we're pretty good. We kind of can do the S's and P's. We move along and we go, all right, 1s2, we're at helium. And then we go 2s2, we're at beryllium. We're good to go. We have 2p6. Now we're at, is it neon? Right? And then 3s2, we're at magnesium. Correct? And then we go 3p6 and we're at argon. Right? So argon's right here. Do you agree with that? And we need to get over here to that spot. what's the next step on our road to get to manganese? These aren't our next step. What's our next step? S's. Don't we have to go to these two before we can get here? You can't just skip this here. So what are these two elements? What subshell are these two elements? Yeah, but what subshell? No. They're the fourth shell. You guys are telling me. They're the S subshell, and they're what shell are they? 4 S's. Then you're going to ask why, right? Your question to me is, why do we do the fourth shell and the third shell's not full? Why do we do that? All right, so this guy named Aufbau, he said, here's the deal. If you're an electron, you're going to choose the lowest energy orbital available. All right, I got 4s. I've got 3d. Which one's the lower energy? 4s. I'm going to 4s. Okay, why is the 4s lower than the 3d? Because you're thinking, well, 4 shell, it's a higher energy shell. But guess what? It's paired with an s. And its pairing with an s makes it less energy than, a little bit less energy than the 3d has. Because the d is really complex orbital. So guess what? He says, okay, I'm going to go the 4s first. But your road to get to manganese tells you have to go through the s's before you hit the d's. So you need to say 4s2, and then what would you write after that? You're in the d's, but what level of d's? 3 d's, because we haven't shown any d's. So that would be 3d what? 5. You guys put 3d7, didn't you? A lot of you?
Yeah.
You did. Okay? If you put 3d7, you're thinking that I'm going to go through the d's and count through the d's in 7. And that would put you farther than you would have for manganese. So if you follow the map, I'm calling this a map, then you now I know some of you are going to go, well, on this periodic table it says 3d5 and then it says 4s2. You know what they're doing? They're putting it always in the order of shell and not energy level. They're putting shells, then energy. Then they're just based on lower to higher shells. You have to go in order of lower to higher. And so 4s is before 3d. Yes, John?
So 4s lines up with 3d, and then 5s lines up with 6d?
5s lines up with 40.
Or 40, I mean?
Yeah. Now, because this is what happens if we look at that drawing. We look at a drawing, we go 2, they're filled. 8, they're filled. That's S's and P's. Then we come to here and we fill in 8 of them. And at this point, what element are we at on the periodic table? There's 2, 8, 8. We're at what? Argon. Guess what? Where those next 2 electrons, they'll come out here. And they'll be put in these S's out here. Then, guess where we go after that? Back here. And how many do we put in here? If we count all the way across the D's, how many is that? How many is in the third shell? 18. Okay? Then after those are filled, where do we go? So after the D's are filled, what section are we in? So after we go through all of these,
4s, 4p.
where are we at?
4p.
P's. What level of P's? 4. Right? And we fill in those. There's 8. Okay? Then we go next where? Now we're down at the S's. Where are they at? Right? 5s. 5th row, 5s. What's the most that the outer energy level can have at any point in time? What's the most they can have out there? Yeah, but when we go through this sequence, what's the most as we go through this process, what's the most? Because this was 8, and this went to 2, and then we came back down and did 10, came back and did 6, right? Then we come up to do 2, then those 2 are filled, then where will we go? Back down here and do 10, then come back up here and do 8 or 6 more. So what's the most that the outer shell can have at any point in time? 8. So the outer shell, we're going to get what we talk about. Did they do that in the video? Talk about the octave? They talk about an octave and that the outer shell is going to always have 8. Okay? So this is what I want you to do. I'm going to give you 4 to practice. Okay? The 4 I'm going to have you practice for tomorrow. Boy, you guys have a lot of time to ask questions now. I want you to do element 16, sulfur. Devin, did you get all that? Kinda. Okay, so I'm going to have you do element 16, sulfur. All right, and then I'm going to have you do element 35, bromine. Both of these do longhand. When I say longhand, you start at hydrogen. Oh, I didn't do shorthand, did I? Okay, I'm going to show you shorthand off of the one we just did. Okay? So, I want you to do cadmium, which is element 48. And I want you to do cesium, which is element 55. Okay, I got to show you the shorthand of noble gas configuration based upon one we did up here. We do not want to start at hydrogen every single time. So here's, you guys can probably look at the configurations that are written out for you on that sheet, on your laminated sheet. Tell me, where do you think the starting point will be for every element if we want to shorten it up? Look at your chart. You got to look at your chart and look at the ones farther down. Tell me which elements are being used as a starting point.
The first one.
The last shell. Yeah, the first one in the period. The last one in the last shell.
What do we call that? What do we call this group? Because they're all in brackets, right? Can you look at them? They got krypton in there, and they got argon and neon, don't they, in brackets? So what they're saying is we're going to start, that is our starting point. So if we did manganese shorthand, this is what we would do. I'd go, I'm going to pick the noble gas in the period or the row above manganese, and I find it. Is it argon? So I'm going to do it down here. I'm going to go argon, and I'm saying that's my starting point. And that's like knowing all of this and not writing it down. I'm not writing any of that down. I know all of that. Because when you do it for me, you're going to go ahead. You're going to go ahead and start from that point. So what's the next 2 elements after that point? Potassium and calcium, right? So what are potassium and calcium? That is what? 4s2 up to that calcium, right? Then I'm going to go what? 3d5. I'm done. You have to know where they come in. That's the only problem. If you do, you know. So then, let me show you the orbital notation for that, and then that one we'll pick up as we go. It's not as important as electron configuration right now. Okay, and so that's the orbitals. Why does the D get 5? No. What? Why do the D's have 5 lines? Because it's what? Yep, 5 pathways. Yep, Chloe.
Because it's 4S1, right?
4s2, 3d5. Did I? That's,
No, she's talking about for,
If on the table, it says, it goes, it starts at scan.
yeah. That's one of those ones that we don't go. AP Chemistry usually had to figure out that and the reason why. But you guys, to get it right, you want to write it like we did. You want to write it like, you want to write, which one are you asking about, chromium?
oh, CR.
Yeah, that one you would write, if you do it our way, it'd be 4s2, 3d4. And the reason why it's that way is something way beyond you want to know. Okay? You don't want to know.
I know.
No, that's a good observation, because if you look at some of them, they actually are borrowing one from the S and putting it over in the D's. And the reason why they're doing that is because they want to fill up the D's halfway before the S fills up. It's kind of goofy. Okay. All right, do those. For the last two, you guys can do the shorthand. So for the last two, if you want to do the shorthand with cadmium and cesium, you can do that.